All right. So I don't have much to talk about today. Um, we covered pretty much everything last week. Uh, but because of those issues that we had at the very end, I want to just go over those problems and kind of like maybe then take advantage of this time to kind of quickly recap the whole um, project and the ideas we covered, so it's clear what we did and how to get things correctly working. Um, so just a quick recap. Last time um, we worked in 4 different topics that are related to assignment 4, and they are how to generate a sphere, then how to pass normals uh, to the vertices of this sphere, and then how to pass a normal matrix, and later how to compute the important vectors for the Phong illumination model. And at the very end, we got stuck in a bug where we couldn't see the diffuse light. We were just seeing like a black canvas, and then later I figured out what was the problem. So let me just go over what was the problem, because the code that I posted on Canvas is actually the fixed version. And the last thing we did was we computed this V position here in the shader based on the A position times the model matrix. So this is the V position in the world space. So this is moving, or let's say mapping or transforming, I think is a better word, transforming A position from object space to world space. This was the last thing we did, but still it wasn't working. And it turned out that the normals of the sphere was wrong. They were wrong. So everything else here was just fine. Here's our calculation for our diffuse component. Later, what I did also, I added the ambient and the specular here just as a template. So they are all actually all zeros here. Let me actually put this back in. So I submitted a code like this, where you have actually one line for the ambient, one line for the diffuse, and one line for the specular. And then here at the very end of the fragment shader, we combine these 3 components. But note that I put like a comment here, to do, and here to do as well. So these are just templates. It's your job to go and actually implement these lines. They are all going to multiply by the base color at the end, and base color here comes either from the texture or from the vertex color. So this line 60 here already supports textures or base color, or let's call it vector color. So we can give a solid color to the vertex, or you can read it from the texture, or you can even blend the both of them, right, using this T parameter here. But then this final color here goes into the mix of the illumination model. So that's why for every line here, I have this multiplication for base color, which in our illumination model, let me just Phong illumination model, we were looking at this article here. So in this article here, you see that these 3 lines here, pretty much you have to grab these 3 components here. This is the ambient component, this is the diffuse component, and this is the specular component. The diffuse one is already here. And KD is KD in the formula. L is the L hat. N is the N here. But this IMD here is what I'm calling base color, okay? So this is going to be the same for IMS. It's going to be also base color, and IA is going to be also base color in our code. Just want to point that out. Now, so when you're reading this formula, if you're following this article on the Wikipedia, these I's are going to map to base color. Okay. Then KA maps to right now here we are passing. We are not. You don't have a KA, but you're going to have to create one. So you're going to have to create a KA and a KS. We only have a KD here as an example. Okay. So the diffuse is pretty much done. And let me show you how this looks like. I'm going to bring back to how it was in the beginning. So in the beginning, we had a red. Actually, it was just a white sphere. So remember, the second argument here of the sphere is the base color of or is the vertex color of the sphere. Is the kind of and the base color here is going to be also our what's called here the I component, but this is our kind of sphere color. And if you render this, wait, let me put the light also, the light position at 0, 10, 0, so it's up. Oh, it's not updating. Let me see what's the problem. It's probably like just a cache. Let me. Yeah, this looks correct now. So see, my light it's up here, so the bottom is completely dark. Right, this bottom here is completely dark because my light is here. If you look at the formula, and we see the diffuse light as blue, because if you go to our shader, our KD factor here is 001, which is blue. So if you change this to be 1, then you get red color, or red diffuse component. See, this is the diffuse component. So this is how it was supposed to look like in the last assignment. Here we could also have, let's say, a white diffuse color, you know, and so on. And note that we can combine these things. Like if I keep it red, but here also if I change my light, if I change my sphere color to be 0.5, for example, on the red channel, see it's gonna get darker. And I'm actually decreasing the intensity because the reflection of, so we can treat this as kind of the reflection of the sphere, right? So this is the amount that it reflects the red channel. So if I put 0, it's going to reflect 0%, and then even though there's a light, now I see fully dark because this material doesn't reflect any red. But I can increase this to 1, and then get full reflection on red. Right now I have the whole refraction there. And if you change this light position, we can see how this is going to look like, right? So if I change it to, I'm moving now my light on the x-axis here. And if I move it, keep moving it, I see how that affects the position of the light. So now the light is kind of up here, and I can make it, I don't know, maybe this won't change much, but I can change the Z here to be 10 now. This is going to be a little bit closer to me. No, actually further from me. It's behind the sphere now. If I want to make it closer to me, I put -10. Now it's going to be closer to the camera, and you see actually that the light is actually, we can see more of the front of the sphere now. One thing you can try is actually making it also 0, 0, -10. So now the light is exactly at the camera position. Actually, let me double check. So actually no, the camera is at -5. So I'm going to put here -5, and now the light and the camera, they are exactly positioned at the same point. So let's see what we get. We should see it like see, we see the full front face, this full like front of the sphere. But if you go probably behind, then you won't see anything, okay? Because the light it's actually is like there. We don't see the kind of a light bulb, or like there's no image for the light, but it's right there, okay? So it's important to play with this light position and see how it affects your sphere before doing anything else. So make sure this is working, and then make sure your ambient light is working, and then make sure your specular is working. So once you do that and fully understand all these components on the sphere, then you can actually move this light source to a bigger world or something like that. So again, the problem with we didn't get this last time because remember when we created our sphere, at this point here, like line 42, for example, we were concatenating the normals of the sphere. And we got it right for I think the first ones, but then we just copied the wrong normals here. So these three lines were wrong. So the normals were incorrect, which made us like not see the diffuse light correctly. But that was the only problem. If you look at the YouTube videos, you'll see that these lines they're not right. And these lines should be equal to this. These lines should be equal to this, and these lines should be equal to this, and they were not in the YouTube video because we just copied and pasted, I think, from the top here, and we forgot to fix. I can show that working now. When you actually put your normal here as a color for the sphere, that's how you should see it. Remember that we could see. I even mentioned that in the video that I was concerned about. I could see the edges of the triangles, and so that was kind of an indication that the normals were wrong. But I kind of kept going, and unfortunately, it was a big problem. But you should see a smooth transition of color when you actually give the normals as colors in the fragment shader. So this is a nice way of debugging your normals. When you're implementing your normals, make sure you get this when you just give the normal as your final color. But I think that was it. Other than that, everything was fine. The sphere is generated correctly. It didn't change anything there. The shader, I just like kept these lines here for you all to kind of understand how to make the ambient and how to make the specular. Just gonna have to finish these parts here. So they are all zeros. They're just placeholders. But you're gonna have to compute something in here for this and in here for specular. But see that I already sum the three of them, so you don't have to worry about it. Also here, there's another to do, which is pass this as a uniform. It would be nice to have this defined in the JavaScript. The KD, the KA, and the KS, they should be, not even like highlight this here. These should be, defined as a uniform and passed to the shader. Any questions on this? Okay, so since we are here, I think I'm gonna, so yeah, I don't have anything more to talk about. I think since you're here and I just created this KA here, I don't think it's a big deal. I'm gonna actually make the ambient component here as well because it's pretty simple. And let me just move the camera back to 0, 10, 0 because I like it. It's easier to visualize, I think. Put the light up. Yeah, light at 0, 10, 0. And then here, the ambient component, if you look at the Phong model, it's super simple, right? It's just Ka times Ia. So we already have Ka here. I'm gonna make Ka red as well, okay? So if I make Ka red, and I just do here Ka And Ka, remember that base color is our I. So Ka times I, that's it. That's the ambient component. So if you do that, I just want to show how the ambient looks like. So see that now we got the whole thing red. But that's because the Ka here is all full intensity. Kd is also full intensity. So we get this full bright red. But if we decrease the Ka to be, let's say, 0.5, see that now you get the top here like brighter and the bottom like with less intensity. If I put this 25, I see even like now I see a little bit of red here, but the top is bright. So the ambient light, it's kind of this idea of this global light that is affecting every single fragment, right? I like thinking of the ambient light as this kind of the light that is kind of reflecting on every single fragment every time, and it doesn't have a position, right? It doesn't have a it doesn't depend on any position of the light. So if you think about this component, right, it doesn't even consider the light direction. So it's just a value that we multiply by a constant, actually, that we multiply by our color. So we can think of this as a weight that controls the original color of the object. So it's a very simple kind of model that literally just like can apply a simple weight on this original color of the object. But that's the ambient light. And if you for example don't use a diffuse light here and only use an ambient, you see that now you see how this ambient component affects the whole sphere regardless of light position, right? And then here I can play with it. And if I put 1, I get a full red, bright red. And if I put 0.5 again, I get less intensity of red. If I put 0.5 in here, let's see what happens. It doesn't do anything, right? And even if I do, even if I, for example, do 0.5 here, we're gonna probably see dark. Okay, and why is that? Because our base color, or our base color, see, so this is 0, Ka is 0, 0.5. And our base color, let's go down there. Our base color is 1, 0, 0. So when you multiply element-wise 1, 0, 0 by 0, 0.5, we get 0, 0, 0. So that's why you're seeing black here, right? So if I want to see some blue in there, because this is 0.5, I have to come here and put some blue. I want the sphere now to reflect some blue as well. So if I put 1 here, now the sphere reflects blue, and now I can see some blue. I can maybe decrease this as well to 0.5 and have now my sphere reflects less blue. So also this makes the sphere a little bit darker. So we have these two parameters to change. You know, we have the element or the object reflection weight or reflection coefficient, and we also have the light color coefficient or something like that. Or here they call it so Ka is the reflection constant, and our base color here is actually mapping to I, which they call it here as like in light source intensity. So yeah, it's a little bit I think the names here, they don't match very well the article. I'm sorry for that, but also these names keep changing from source to source. So it's important to know what's going on. But for our source code, we have these bindings of variable names. So hopefully you got the idea, and you could play with this for as long as you want. I'm just going to put the diffuse here. And see that the diffuse, this is a cool effect, right? The diffuse is red. Diffuse is red, and the ambient is blue. So we get some sort of like magenta here on top because they're blending, right? So yeah, you can play with this to try to understand what's going on, and I think that's a very important exercise. What else? I think that's it. I mean, I wanna leave the KS or the specular as an exercise for you guys. So I think that's it. And we're gonna just finish. Like, if you don't have any questions, we're just gonna finish very early today.